Page 4. A couple of multiple choice that have to do with our understanding of heat. We have to be able to relate the idea between thermal energy, phase energy, and then there's another one that we didn't really deal with, which is chemical. So we're simply looking at thermal versus phase. When a sample of liquid is cooled, it's thermal energy. If I'm cooling something off and it's really liquid, then if I'm cooling it off, its thermal energy will simply decrease. But while it's freezing, number 12, while a sample of liquid is freezing, its thermal energy, once it gets to the freezing point, it does not change temperature anymore. It just loses energy as it freezes, so its thermal energy remains the same. It's the phase energy that's changing. Graph at right represents the temp time behavior, what was initially a sample of ice. So I have ice. Once it melts, it must be a liquid. And once it gets to this point at C, it must be evaporating, but it's not steam yet, it's the process of evaporating. So these, during region B, what is the thermal energy doing? Well, I can see that during B, the temperature is going up, so the thermal energy is A, increasing. During region C, though, the thermal energy, it's not changing temperature. It's changing phase, but it's not changing temperature. So its thermal energy is simply remaining the same. During region A, the phase energy, it's in the process of melting. So it's going from a neat organized phase into one that's spread out more. That is an increase in phase energy. Next one, drawing some of these charts. For each of the situations described below, use an energy bar chart to represent the ways that energy is stored. A cup of hot coffee. So the first thing I'm going to do is I'm going to write in the system what it is that I'm paying attention to. It's the coffee itself. It starts off as it starts off hot, so I need to assign it a certain amount of thermal energy. I'll say it's pretty darn hot. I'm going to give it 1, 2, 3 bars. But if you only went 2 or if you went to 4, that's okay. But it cools off as it sits on the table. So later on, I got to finish drawing this in. Later on, at the end, it is not going to be as hot, so I'm going to say that it came down to this level. Another thing to consider is the phase. The phase always works like this. Solids are 1 bar. Liquids are 2 bars. But if you have a gas and it's bouncing out of the container, that's 4 bars. Well, this is liquid coffee. I'm going to give it 2 bars. And at the end, it's still going to be liquid coffee, 2 bars. So what do I have total? I have 1, 2, 3, 4, 1, 2, 3, 4, 5 bars on this side. But on this side, I only have 1, 2, 3 bars. 3 bars on this side. That's a difference of 2. So it's a change of 2. It lost that energy, so I'm going to draw 1, 2 bars, and I'm going to show it exiting the system.